normal graph is a problem you did last night for homework. You did page 83, number 2, but you had to evaluate, you plugged in. Today we're going to get a visual of it by graphing it. So you have today's date. You've written the assignment. Our goal is to graph. And this is the one we're graphing. And remember, when you graph a straight line, you're starting at a y-intercept and you're moving rise over run, up and over. Okay? That's what we'll do for these pieces of this function. Oh, how helpful. This is so mad. This makes me so mad. Guess I'm gonna do it right here without math, which is not good enough. I'm gonna try to close this and reopen it so it's not blurry. So it's encouragement. The word. Okay. This is the one we're doing. Alright, so the very first thing I'm going to recommend that you do when you have to graph this is that you write each one of these separately so you can really see what you're working with. So I'm going to do y equals negative x plus 4. So instead of g of x, I'm just going to do y equals this one. And that's the first one I'm going to graph. And then I have to graph y equals 3. This is y equals 3. And then I'm going to graph again y equals 2x minus 5. So I write them all instead of f of x, y equals. Yeah, you're right there. You can move your desk if it's too squished. I don't know why they didn't go back. Okay, so I'm going to focus all my attention on this first one and make a graph. I'm going to move it over. Okay, so to graph y equals negative x plus 4, I'm going to begin my line at the point 0, 4. Oh, and mine didn't get rid of it. There it is, so 0, 4. And then that's a reflection slope, right? So that's the slope of down 1, right 1, down 1, right 1. Everything's in the way here. The negative here is like negative 1, and it's rise over run, so negative slope. Instead of going up 1 over 1, you go down 1 over 1. So really for a piecewise graph, I kind of make it really big. Normally I might do 3 points, maybe 4. And this one I'm kind of extending a lot. So, okay. Step 1 is to write the equations y equals. Step 2 is to focus all your attention on the first equation and fully graph it. Now, before I move on to the second equation, I'm going to look at the if statement that is guiding which x values work for that equation. So, for this one, it says this is only true, or it only exists when x is less than -1. So that if statement has to come into play for our graph. So here's the x-axis, and here's where x is -1. It helps me to really see that. Okay, this is where x equals -1. This isn't a part of my graph, but I need to kind of see what I'm looking at. So I'm actually going to extend this like kind of like a dashed line. This is where x is -1. It's the line is only supposed to live over here where it's less. So none of this is supposed to exist. So I'm now going to use my pencil and I'm going to erase everything to the right of -1 because this is only for x values less than -1. So that's why you're required to have an eraser here. I'm going to change color, open circle, like this. Okay, and there it is. It's like a ray because it has an endpoint and an arrow. Now I'm putting my endpoint with an open circle, and that's because it's not equal to -1. So I have an open circle here, and it goes to the left. And the way they work is it's left, right, middle. Left side, right side, middle. No, left side, middle, right. So this is the left side of the graph. Who's got a question now about the left side of the graph? All right, yeah. All right, here. And I actually am going to give you guys like a lot of notes on this. I'm walking you through it once, and then I'm going to give you step-by-step notes to refer to. So as you're doing it now, know that it's just an introduction and there are like more notes and things coming. But this one, the first one will be the left side of the graph. This one will be the middle of the graph. And then this one will be the right side of the graph. Let's do the second equation. Yeah, that was just helping me understand where to erase. So the dotted line is based on this thing. It says if x is less than -1. So here's where x is -1. And so this should not be existing to the right of -1. Should only work to the left of -1. Let's do the middle. All right. This good? Well, I had the whole line here, right? This is the real one. This -1 is what helped me understand where it should be erased at. So I went to -1. Yeah. Let's do the middle. All right. The middle one is just y equals 3. And this is a constant function in the constant function family. This is a flat, no slope line where y equals 3. So this one, I don't have to worry about rise over run. It looks like this. Y equals 3. Flat. Because there's no x in it. If there's no x in that equation, there's no rise. So run. Now I have to figure out when this is true. So I'm going to check on that if statement. So it says if I already know where x is -1 because I still have that dash line there. So there's where x is -1. It can go all the way to where x is 2, which is right here. So for this flat line, it goes from -1 to 2. And I would erase anything to the left of -1 and anything to the right of 2, because it should only exist in between there. And it's a segment. The middle will be a segment. How's that one? Starting to make a little sense? The homework? Oh, I'll start that in just a minute. I have a whole kind of explanation for that. And the last one, the last equation that we have to graph is y equals 2x minus 5. So that graph will begin at 0, -5, and then it will go up 2 over 1, up 2 over 1. So here's the y-intercept at -5, and then I am going up 2 over 1. And I'll check on the rule for that one. The rule for that one is that x has to be greater than or equal to 2. So this one will only work to the right of x equals 2 because it's greater. So I still have this yellow dashed line for 2. So I'm going to look at where that purple line is that I just graphed. It's going to start there. And it will continue to the right of that, but I need to erase anything to the left of 2. And now we have all 3 pieces graphed. Great. So when I look at this rule, one of the inequality symbols shows equal to, and one of them shows not equal to. When I look at this on the problem, so this means at -1 I have a closed dot, and at 2 I have an open dot. So if you look, not equal to, not equal to, equal to. So we have open circle, closed dot, open circle, closed dot. Let's look at that another way. You should never have 2 closed dots stacked on each other because that breaks the vertical line test of functions. The vertical line test of functions says that you should never have anything overlapping. So this is not like a coincidence that right here we have an open circle and a closed dot. They can't both be closed. It has to be one or the other. Open circle, closed dot. You can't have 2 closed dots stacked. It won't be a function then. It'll break the vertical line test. Other good questions, what you're looking at. Okay, so what I see is I see this game on my phone where I drop balls falls down, and then the marble has to fall a certain way, and that's what this is. Okay, so if you picture a ball falling here, it's going down a certain steepness. It drops here, and then it's rolling flat for a little bit, and then it drops here, and then it has to shoot uphill. That's what you're looking at. You're pretty much looking at a video game or a background of like Mario Brothers, where they're jumping up and down on different platforms. So you read it left to right, and it's not just one flat video game or not one flat hill. It's going downhill, flattening out for a bit, and then rising back uphill. Okay, and that is the background of a lot of the digital, almost all of the digital games we use, and just like piecewise functions. All right. Let me know if you come up with any more questions. Here are the steps that I just walked you through. I fully recommend you read the book steps. I heard someone say they were confused yesterday, so they went to the online book and watched the video, and it helped them. You have a lot of resources with this textbook line. They use the QR code. There's a QR code in your book next to the page, and it took them right to a video link. Can I hold up your page and you have it right now? This QR code took them to a video that helped them with their homework yesterday. Okay? Utilize all those resources. These digital resources. So, what are we looking at here? And these are just like helpful tips. This is exactly what we just did, but right now. So, steps for graphing piecewise functions. The first thing I did with you is I wrote each equation separately as y equals. Because when you look at it with f of x and that fancy bracket, it's kind of hard to, it's so many symbols. So I did y equals, y equals, y equals, so that I systematically take one line at a time. Then I graphed the first line. I drew a dashed line at the if statement to figure out how I was going to erase. And then right here, this might be the most valuable tip written up here, is that if it says x is less than or x is less than or equal to, you erase everything to the right. So if it's kind of difficult for you to figure out what you're erasing, these symbols mean erase on the right side. X is greater than or equal to, you erase on the left side of that. And then you repeat that for all of the different pieces, and then remember to think about open circles and closed dots. That's the process of graphing a piecewise function. I'm going to chill for a while and let you guys read this and think about it and write down what you want. Just so you know, my next move is to answer questions about what we did yesterday. Today's assignment is that. So everybody has something to do. Yes. Mm-hmm. People are just about done writing all this stuff down. Are you guys ready to talk about yesterday's work? Just about. Not quite. Okay. No rush. No rush. I'm good. I mean, that'd be cool. If you finish the feature, I won't give you. Especially since the odds are in there, like I have to know how this thing, or 12 or whatever. All right, guys, let's take some questions on what was happening yesterday. Here's the answers. If you were to sell answers to number one using the back of your book, right? So make sure you're using that as a tool to help you problem solve as well. But what's highlighted in yellow tells you which piece to plug into. So you were plugging in, the first thing you were challenged to plug in was -4, and you used the first equation, which was 5x minus 1. So when you put -4 in there, you get -20 minus 1, and here's your answer, -21. Yes, just plugging in. And the second time, you had to plug in -2. You used the first equation. Put your -2 into 5x minus 1, and you end up with -11. And then you plug in -1. Use the second equation. You get 2. Okay, so the yellow tells you which part you're supposed to plug into, and the blue tells you the answer you should have got out, and then the stuff in the middle shows the word. Yep. Yeah. Totally right. Yeah. So instead of the improper fraction 7/2, she put 3 1/2. The only the only reason that impropers are better is well, it's a little easier to plug into like other equations, but also like on digital tests, standardized tests like the SAT, if you have to type in a fraction on the SAT, you have to type it in this way because the SAT will read this 31/2. Okay, so generally all of my answers will be improper, but as far as anything I grade by hand, you're more than welcome to use a mixed number. Sometimes mixed numbers make more sense. Okay, who else has a question on this? Yeah, let me just go back to the. No, let me show you. Down here, what we're doing today is like you made how to show work. Yeah, just show with the parentheses, like this showed 5 times -2 minus 1. You don't have to show this. Like you can do one less step than this, but does that answer your question? All right. All right, let me give you credit. Let me come around and give credit. What's my book? On that side yesterday. Oh, you did. ask any question when I come back, okay? And some of it on purpose to give you a chance to ask me a question. Okay, let me know. I typically do. Let me know. I need more Yeah, I'm the right G. Whatever. Yeah, yeah, that's good notation.
These numbers only depend on like the plug in only depends on each.
Also, just 2 pages to the left.
Oh, that's Sarasota. This number is greater than the one that was listed. You guys still got, you still got 2 minutes in class. I might be putting answers up here. You just sitting here. It's 3 minutes. You can do a whole math problem in 3 minutes. Listen, this is what I think when I see this situation.
I'm not assigning enough work. That's literally, I'm like, oh man, I should have given more. Like, shoot, we're done too early. Because I'm told to make sure students are working bell to bell. So this sign to me says, whoop, I didn't give enough work. I'm not doing what I'm supposed to be. They're supposed to be working bell to bell. So this, the earlier you guys finish, the longer I make the assignments. Because honestly, I think you should be doing more anyway. Like if you really want to remember this stuff. So I'm going off of your work pace. And if your work pace is super tight that you can just sit here and talk about whatever for minutes, oh, we should be doing more. Like let's get better. Okay? That's what goes through my head. This is what I want you to do. Time yourself. How long does it take to pack up? You might think it takes you a full 3 minutes, 150 seconds. It takes you 10 seconds to pack up. Watch the clock.